So welcome to the afternoon keynote on Wednesday. Most of you have been here before, I guess, for other keynotes, for the ones who haven't. And as a reminder as well, you can ask questions to the keynote speaker using Slido. And you see it over there if you type in your device slide.do. And then you can ask questions and vote questions up. And then at the end, we will take some of them depending on the remaining time. It is my absolute pleasure to have Rebecca Parsons here today. So I was super happy when she accepted my invitation. That was really great. And she's talking today about evolutionary architecture and architectural governance. And I think the difficulty is already in this little word "and", because very often it's more contradiction than anything you are combining. And then on top of it, she's looking at what it means in the future. So looking at the crystal ball, what AI and ML, so artificial intelligence, and for Nico, it's the same as KI, for the ones who have been at the Stammtisch yesterday. And machine learning are adding to evolutionary architecture and architectural governance. So welcome, Rebecca Parsons.
Thank you, Jutta. So I would like to talk about how we develop systems. And obviously, we start with requirements. But as architects, we have to worry about all of these other things: security, performance, scalability, recoverability, all of those different things. And we call these the ilities. And there's a whole lot of them. And some of them are mutually exclusive. We cannot optimize, we cannot maximize both performance and security at the same time. It is simply not possible. But what we want to talk about today is how do we deal with these architectural characteristics when change is happening so quickly. And so we are going to be proposing a new ility. We want to talk about evolvability as one of those things that we think about when we're trying to decide what are the characteristics of the system that we are building. Now, in the good old days, architecture was easy, and architects could plan. When I started, people kept a straight face and talked about a 5- and 10-year technology roadmap. It's just over 10 years since the iPhone was developed. We cannot have the kinds of plans that we used to have because everything is now changing all of the time. Everything. And changing in very unexpected ways. It used to be, at least when you were dealing with your employees, you didn't have to worry so much about user experience because they had to take whatever you got, and green screens were horrible. And I don't know how many of you are familiar with the travel systems, but the physical contortions that those agents have to go through to do some of those commands, that's not acceptable anymore. Even our employees expect the same kind of user experience that they get from Twitter and Facebook and all of the other more consumer-facing. So what we want to talk about is how do we start to plan, how do we architect our systems when what we in fact have is a dynamic environment. This might be because of technology changes, this might be because of mergers and acquisitions, changed expectations, a different competitive landscape. And think about things like Docker. Even if you're not currently using Docker, you have to think about your architectural requirements in a very different way now that Docker is part of our ecosystem. So as architects, we're kind of like this bicyclist. Oops, got a little carried away there. Come on, back. We're trying to keep our balance. Come on. We're trying to keep our balance on a unicycle while we're juggling things that are on fire. And all we really care about is not falling flat on our face. This is kind of what we have to do as architects, respond to these things that are coming at us. And we never really know where they're going to come from. So how is long-term planning possible when things are constantly changing in unexpected ways? One of the questions that we've been asking different audiences like this is, I will bet you 100 euros, I'll take the bet from anybody, if you can tell me for certain what JavaScript web framework you're using in 2 years. None of you could do it, because it probably hasn't been written yet. We can't do long-term planning in the same way we did before. And the second, and this is where we start to talk about governance. How can I ensure that my system does not degrade over time? How do I know that? That's what we need to solve. This is the problem that we're trying to solve, and my proposition to you is we solve this through something called evolutionary architecture. Now, when you read a book that coins a new term, picking that term is very important. And both Neil Ford, my co-author, and I have been talking about evolutionary architecture for a long time. The first time I heard Neil talk about it, though, he called it emergent architecture. And he and I had a very robust discussion about why that was a very bad name for it. Because when you hear the word emergent, it really evokes kind of that unicyclist. I'm just going to respond in whatever way possible just so I don't fall to the pavement. But architecture is different. I'm perfectly comfortable talking about emergent design because for the most part, all of us will agree on what constitutes good code, what a good design looks like. But that's not the same thing as architecture. I worked early in my career with ThoughtWorks on a trading system. Now, when I say trading system, everybody thinks high throughput, low latency, got to keep it moving. This organization, in their wildest dreams, figured they would do 200 transactions a day. They didn't care about latency. They cared about never losing a message, because each one of those trades was worth billions of dollars in the year 2002. So what constituted a good architecture for that trading system was very different. What constitutes a good architecture depends on your application, on your organization, on your domain, the regulatory frameworks, all of those different things. Another example, I was working with another client, and they really wanted a centralized architecture. And so we went to them with our first proposal. And this is what they said, and I quote, "But what happens when we lose Scotland?" And I looked at them, I said, "What do you mean?" What had happened many years ago with a freak communications failure, they had for multiple days lost communication with all of their offices in Scotland. The organizational memory was so hard in that organization that they could not actually have a fully centralized architecture because it would not be resilient to yet another freak communication failure. I strongly suspect none of you have ever had that as a requirement unless you happen to work for this organization. So what constitutes a good architecture varies. And so we can't just have some definition. And so we call this evolutionary architecture in the guise of evolutionary computation. So now here's our definition. An evolutionary architecture supports guided incremental change across multiple dimensions. And each one of those three words are important. So the first, guided. As I said, what constitutes good varies from system to system, so we have to define it. If you think about evolutionary computation, something like genetic algorithms, you have a fitness function. And that fitness function tells you how close you are to a good answer. I'd like to give you an example. I was at a genetic algorithms conference many years ago, and there was a group that was working on a genetic algorithm to design an airplane wing. and their fitness function was aerodynamic efficiency. And when they ran this, it came up with this funky design that had all of these different things sticking out at weird angles. And of course, the aeronautical engineers looked at it and said, you've got a bug in your program. But they did the calculation and found out that yes, it was in fact more aerodynamically efficient. It might not have been able to withstand air flight. It was certainly more difficult and more expensive to manufacture, but aerodynamically it was correct. Your fitness function is important, and you have to think about all of the different aspects of this, because that is what's going to guide your architecture. And so what we're saying is we need to, that's interesting, we need to have a fitness function, or actually several fitness functions, that capture what it is that we want our architecture to achieve. The single most important thing about a fitness function is that you and I will never disagree about whether it passes or not. So maintainable is not a legitimate requirement. Much like what we did in Agile software development, where we told our business users, you have to give me an objective definition of done. And then I will tell you I'm done when that acceptance test passes. That's what these fitness functions are. They are an objective definition of what we're looking for a particular architectural characteristic. And so we have to think about, in that whole list of ilities, which ones are important to us, and what level we need to get to, what level of performance, what level of code quality, what level of scalability. We're going to define different fitness functions, and it is this collection of fitness functions that tells, for my organization and this application in my domain, what constitutes good. That's what we mean being guided, because our architectural decisions are now going to be guided on the basis of these fitness functions that we have defined. The next is incremental. When we are looking at incremental change, what do we mean? From an architectural perspective, there are two different aspects that we have to worry about. The first is, how do we swap things out? How do we evolve the code? How do we replace old components with new components? And there's all kinds of techniques that I don't really have time to go into right now that are used to support this. But the other aspect of incremental is really across the development process. How do we continually ensure that we are meeting our architectural objectives? And we use a deployment pipeline. When I first started talking about evolutionary architecture, I would have people come up to me at the end of the talk, kind of whisper in my ear, don't you think you're being professionally irresponsible for advocating such a bizarre notion as evolutionary architecture? Architecture is the rock, it's the foundation. How can you say you want to change up the foundation? I will tell you that without the disciplines that have been introduced with continuous delivery, it probably is professionally irresponsible. Because we're talking about changing fundamental characteristics of a running system. But deployment pipelines allow us to continually monitor, as we're changing the system, are we still achieving the objectives, both the functional objectives and our architectural objectives, by using that deployment pipeline. So that's what we mean by incremental change. We want to be able to change things out over time as our requirements change, as the competitive landscape changes. And then across multiple dimensions. As I said before, we've got all of these ilities running around, and we have to figure out how we're going to balance these things. As architects, one of our most common words is trade-off. How do I make the decision between the level of security and performance, data liveness and caching? All of these different things are across multiple dimensions. So there's our definition. But what does this mean for governance? When we start thinking about architectural governance, how are we going to do this? And fitness functions actually provide us the mechanism for doing governance. If we could specify these criteria, these characteristics, these architectural requirements through a fitness function, then we can stop thinking about them. Because the build is never going to pass if we're violating one of these. So the more of these things we can get into the build or get into some kind of monitoring system, the more we as architects can focus on solving the more difficult problems. This is what a target architecture looks like now. It's a system-wide fitness function. You will probably never execute this fitness function in its totality at any given time, because there are lots of different kinds of functions. But what we are doing is saying, this is what we want our system to be. This is what constitutes good for our system. So the target architecture is now this system-wide fitness function. And an important characteristic of it is governance relies on these functions, but we've moved our target architecture away from implementation to outcomes. We're not trying to specify this is how you have to do it. We're trying to specify this is what you have to achieve. And by doing that, our implementations become more robust with respect to the different kinds of changes that might happen. Because we aren't going into this with the idea, here is a particular implementation. We're going into this thinking about what's the outcome that we want to achieve. And so when we have a brand new technology that becomes available, we can look at how we might use it. Think of the differences between using a relational database and many of the NoSQL databases. For a long time, you couldn't persist anything unless it was in a relational database, which came with all of these characteristics. ACID. And we knew all about relational databases, and we didn't have to worry about things like an inconsistent state because you just couldn't get into it anymore. But if we were focused instead on what are the requirements for transactionality, is eventual consistency all right? If we were focused on that, then thinking about switching from a relational database to a document database would look very different in that context, because we know what it is that we have to achieve for those particular aspects of the system. So we want to focus this thing on outcomes. Now, fitness functions are nothing new. These are metrics. These are unit and acceptance tests that you might put in your build. There are all kinds of things that we've seen out there, and I will give you a few examples as we go through this, that is a fitness function. But what we're doing here is we're unifying a lot of the different processing that happens and a lot of the different thinking and governance that goes into architecture under a common framework. So now we can start to make some of these trade-offs, because we also start to understand what it actually costs to achieve some of these characteristics. So what are some possible categories of fitness function? Well, the first one is relatively simple. You might have an atomic fitness function. You might have a holistic fitness function, which is looking at multiple characteristics. You might have a fitness function that's triggered by some action. Very often these are put in a build. But we also have continuous fitness functions, things that just run all of the time. We have static fitness functions that always returns the same result, versus dynamic, where that result might rely on context. You might get different performance characteristics based on network load in another part of the network. Now, this does not counter what I said earlier. You and I have to agree whether something passes or not. That doesn't mean the value can't change. Automated versus manual. To the extent that we can make these tests automated, it makes governance so much easier. Because as soon as you have an automated test, you don't have to do any kind of governance around that characteristic anymore. But some of these you might want to be manual. Nothing wrong with that, as long as you and I will never disagree. Some of them might have a time aspect. Think about, for example, library upgrades. You might want to break a build immediately when a new version of a new library comes out, perhaps one that is fixing a zero-day exploit. Or maybe you want to have a timer in there. Okay, I'm going to give the teams 30 days. And the build passes, and the build passes, and the build passes, and then 30 days hits, and it says, nope, you've outlived your window of grace. Now you have to go upgrade the library. Now, one of the most common questions that we get asked is, where can I go on the internet and download all of the fitness functions I need for my banking application? And our response to that very often is, where do you go on the internet to download all of your business requirements for your banking application? These things still vary. But there are some things that you might think about as more domain-specific fitness functions. I would probably still argue that they're actually requirements, things like GDPR compliance, but you do get some of those things, health data protection, for example, that are different and very specific to a domain. You might consider it a domain-specific fitness function. I don't know that that's a useful characterization. There are intentional fitness functions, things that we know about going into the project. And of course, the world being what it is, there are some that are going to emerge based on maybe a change in the competitive landscape, or AR and VR suddenly become enterprise requirements, and that's going to introduce a whole new set of things into your requirements. So how about some examples? Let's think about something simple. You've gone on a quest throughout your code base to eradicate all cyclic dependencies. And this is actually true for many different kinds of code cleanup activities. There's always this nagging, but how do I know they're not going to come back? There's a package called JDepend. You stick this in your build, and no build now will pass if somebody has introduced a cyclic dependency. This is a fitness function. You can also have things that help you maintain your layers or the proper coupling between components. It's okay if people rely on util, but you don't want util to rely on web. There's another fitness function. Now, these are things that you never, ever have to talk about in a code review ever again, because you can't check in any code that violates these rules. Let's think of something different. We have lots of different development teams. And we want to be able to develop things independently. So we use tests to document the assumptions that we're making about each other. And then we cheerfully ignore each other. I can do whatever I have to do, and I don't have to talk to anybody until a test breaks. And once that test breaks, I go and talk to that person, and I say, okay, I'm having to make a change that is breaking something that you're assuming about me. I don't have to talk to any of the other people. Their test didn't break. We work out our differences, we write a new test, and then we go back to cheerfully ignoring each other. These tests are actually documenting the assumptions that different parts of the system are making about each other. Some of the best enterprise architects I've met have these things in their head. They know when it might seem perfectly logical to do this, but we tried that 10 years ago, and it failed miserably because these systems interact in ways that are not obvious on the surface. This is a different kind of fitness function. We're getting more and more tools that will allow us to do this. ArcUnit is a good one that allows us to look at different characteristics. You can do something simple, like make sure interface classes don't end with the name interface. Again, you never need to talk about this in a code review. There are other things that might make sure that you're using libraries properly. So that maybe you have a library that for security purposes you always want to go through the wrapper. You can put those kinds of things in ArcUnit. And these things are very easy to read. Maybe not on that screen. Interfaces must not be placed in implementation packages. Very often, as architects, because we're outnumbered in general, these things will be written down in a book someplace that nobody reads. As soon as you implement them, people have to follow them. Now, unfortunately, this means that if you have a truly draconian enterprise architect, they can put all kinds of straitjackets. I'm sorry, but we cannot solve all the people problems. This is a tool, like any tool, that can be abused, but the benefits are enormous. Because as I said, all of these things that you put in there, you never have to think about anymore, because nothing will get into your system that violates any of those rules. Let's think about something different, how we might monitor in production through something like synthetic transactions. Maybe we're going to be monitoring the performance or the response time for these particular transactions. This, again, is a fitness function. It's going to be making sure that these transactional characteristics that we've specified in whatever is monitoring this transaction still hold. One of the most interesting fitness functions, actually a collection of them, is the simian army. Netflix invested an awful lot to put the simian army together. But as a result, their system is far more resilient. And in fact, when Amazon lost one of their entire zones, Netflix still ran because they had something in the simian army that simulated that. If your restful endpoints are misconfigured, there's part of the simian army which will kick you out of production. So once again, you never have to think about these things from a governance perspective. The fitness functions are doing that for you. And that means that when you come up against something truly difficult, how do I handle this eventual consistency? How do I make this trade-off between data staleness and my need for performance and therefore caching? Expensive architects can focus their brain power on the things that need a brain and leave the more mindless, are we respecting our package structure requirements, to the fitness functions. So this is how we do governance in the new world. We implement all of these things as fitness functions. But how are we going to make this work when most of us are actually working in a brownfield? The first thing you need to do is identify the dimension you're most worried about. Note, I did not say the dimension that you think you're that is going to change, because we are not trying to predict what is going to change. Rather, where are you most worried? Is it performance? Is it instability? Is it integration? What kind of defects come up when you deploy things into production? When does your support crew get nervous and cancel all of their vacations when they find out you're changing a particular part of the system? Figure out where you're most exposed, which of these dimensions, and define a fitness function for it. Figure out for that, where do I want to get to? What is the outcome that I want to achieve for this characteristic? Now, if is typical, you're far off from where you'd really like to be on a fitness function, you probably don't want to start breaking the build. But you at least want to monitor how you're doing. Figure out what good looks like and start to measure it and start to move closer to it. The nice thing about these fitness functions and monitoring them over time is it addresses that question of how do I ensure my system is not degrading over time. You're ensuring you're not degrading because you're constantly running these things and you're knowing when things are changing, when things are going wrong. And then you use your deployment pipeline to put these in. These deployment pipelines give us the ability to start to slot different kinds of checks into our system. Let's go back to the zero-day exploits. What if every application that you had actually had a build pipeline, and your security office found out about a zero-day exploit in a library that's commonly used? They could drop a fitness function that checked the version number of that library and trigger a build for every application. And now you know where you're exposed and you can prioritize your efforts for fixing the zero-day exploit. You don't have to rely on a list somewhere. And in fact, something like this went horribly wrong with one of our credit bureaus in the United States. They had a zero-day exploit. They didn't find all of the instances of the use of the library. And that's how millions and millions of records were hacked. Putting these things into the deployment pipeline ensures that at least you know what your problem is. It's not going to fix it. That's more where the future stuff comes. But at least you know that it's there. And then, of course, since everything is always changing, you keep repeating this cycle. You should be constantly reevaluating your fitness functions to ensure that they still match what the environment looks like. Because this environment is changing. What constitutes good changes over time. So now let's talk a little bit about that future. We're still in the very early stages of figuring out how we encode some of these things as fitness functions. Some of them are very straightforward. We know about static code analysis. Netflix is doing some fascinating things with the simian army. But what about other things? Where can we start using machine learning systems? They've been used in fraud detection for years. But we can expand that. What might we do in terms of trying to understand, say, the performance characteristics by monitoring and having a learning system looking over those synthetic transactions? Maybe we want to think about something like code analysis that can start to tell us not just where our vulnerabilities are, but maybe start to actually do some of the refactorings, find some of the patterns for where a vulnerability is and fix it. We've got lots of potential for thinking about both simple fitness functions and much more complicated fitness functions. One really nice example of a very simple fitness function. One of the clients we deal with, their lawyers got all nervous about open source licenses. And so they had to go and collect all of the open source licenses, and the lawyer had to sign off on them. And then the lawyer asked that pesky question. What happens when somebody changes a license? How will we know? They all have lawyers, right? And the lawyers are going to call everybody that uses their library. Well, of course not. They're never going to do that. The simple solution, and I thought this was really clever, what they did was they actually hashed all of the license files and put something in the build that every time it went to the open source library, it rehashed the license and compared the hashes. And if the hashes were different, it failed the build. And so they called the lawyer. Now, eventually, it would be nice to be able to do some kind of natural language processing on that license file and figure out whether or not there really was a substantive change, and only call the lawyer if you really needed a lawyer to look at it, until such time as we've automated away all the lawyers. But for the time being, that's a perfectly adequate solution, because what you really need to know is, did that license file change? So you hash it. One of the things that we're doing is collecting on this website, evolutionaryarchitecture.com, various examples of fitness functions. And so we have actually fitness function katas out there, which gives you a problem and then also a solution to that problem. You can see the solution by doing one of two things. For the URL for a particular fitness function kata, you add solution equals true, or because Neil is lazy and he implemented this, s equals 1, and it will show you the answer. And we have people who are sending us, hey, I figured out how to write a fitness function for this. And we're adding it to this website so that we can start to understand what are the different ways that we can be clever about encoding some of these architectural requirements as fitness functions. Because one of the issues that we have is, how do we translate these requirements into a fitness function? How far do we want to push it? Do we want to do something clever, like natural language processing on the license file? Or do we want to do something dead simple and just fail the build if something changed? How do we encode fitness functions? What are the other possibilities that might get added into the simian army for the things that we might want to monitor in production? So there's, how do we apply future technology, but also how do we start to encode some of the new kinds of requirements that might come up? If you think about, for example, how a user experience and the potential for harm from things like virtual reality, how would you potentially start to encode fitness functions about the way a person is interacting in a virtual world to determine that perhaps there's no exploitation going on? All of these things we have to think about. What are the ways that we can automate this governance? Because our systems are not getting simpler. They're getting increasingly complex. And no matter how good we are, we can't keep track of all of those different things. Again, that's part of what the fitness functions are for. We want to be able to automate away as much of governance as possible so we can all focus on the really difficult problems. How are we going to solve that problem of eventual consistency for that particular data? How are we going to balance these architectural trade-offs? So that's what evolutionary architecture is about, and that's how evolutionary architecture can provide a completely different basis for governance in architecture. Thank you very much. So how do all these questions work?
Me too, because I lost the connection.
Oh. Okay, it looks like we've got it on the monitor.
Yes, so we just use that list. So we start with the first one. Writing tests for abilities is, in my opinion, a best practice for years. What is the difference related to naming them fitness function? Actually, there were a lot of questions around that. What's the fitness function compared to like system tests or non-technical requirements? So all kind of, and I guess this is also a bit in this direction.
Well, as I said, fitness functions aren't anything new. Part of what we're trying to do, though, is yikes. Standardized nomenclature. So we deal with all of these things in the same way. You will also hear people say, can you still hear me?
I think yes.
Yeah.
Wait.
We'll just do it this way. I've also heard people say, well, we were doing agile software development back in the 80s. Obviously, people were doing some of these things. The fitness function nomenclature, though, is helping focus on the kinds of changes we want to enable. When we were writing tests before for, say, a load test or number of simultaneous users, that's a pretty standard test. We didn't necessarily have the mechanism to make it easily repeatable. In fact, we still don't really have a mechanism to make performance tests easily repeatable. But by calling it a fitness function, it is really a mindset shift that is saying what we want to do is specify the outcome that we're trying to achieve. And very often, particularly when you think about architectural governance, it's far more about things like your cyclomatic complexity cannot be greater than 50. You need to name things this way. By changing the name of the thing that we are writing, it focuses the mind more on this is the outcome that I'm trying to achieve, and this is the characteristic that I'm trying to maintain. So it's not this, great new idea. It's really changing the way we think about things that many people have already done. The other important thing is it does make it critical that you can actually specify objectively what that is. And in many cases, architectural requirements were never characterized that way.
Okay, what would a fitness function for usability or changeability look like?
Usability or changeability of code?
I guess for architecture.
Okay. One of the most important things to being able to change something is to be able to understand it. And so many of the fitness functions that we talk about with respect to how easy something is to change have to do with how easy it is to understand. So architectural complexity, coupling, how different packages depend on each other. Do you have the right structure? Do you have the right integration points and enough information about how those integrations work to know when something is properly integrated? So it's all around being able to understand and then have the proper separation of concerns so that you can, in fact, change things.
Mm-hmm. Then there is this comment, I always feel evolutionary might not be the best term for what you describe. Isn't evolution by definition random and unguided? Survival of the fittest.
Biological evolution is guided by survival of the fittest. That's why the analog is actually to evolutionary computation. We also try to distinguish this from things like adaptability. Because most people, when they hear adaptability, they think, that means I have an adapter. I've built some code to make me more resilient to a change along this dimension, which means you're back again to predicting what kind of dimension. The nice thing about evolutionary is you are thinking about, I have to respond to my environment, whatever that environment looks like.
And well, we are kind of at the end. I try, maybe this is fast, but I'm not sure. Can you show a real life example of a fitness function? I know that you have shown some code, and I think the question came before that, but maybe you can still
Okay.
try.
Some other ones, other than what we talked about there. Obviously, you can have something very simple, like cyclomatic complexity. When you think of different kinds of architectural styles, you might have things that allow you to enforce layers. You might have fitness functions that ensure you have proper circuit breakers if you've got a particular kind of architecture. So there are lots of different examples. The easiest ones to come up with are either things traditionally around performance or around the static code analysis. That's why I tried to use things like the fitness function to detect when an open source library changed. That's a completely different kind of fitness function. But I would also encourage you to go out to the website and just look at some of the examples that are out there.
That's actually a very wonderful closing, because there is a lot of stuff out there, and also, of course, in the book about building evolutionary architecture, which you wrote. Thank you so much, Rebecca.
Thank you very much.